students, myself Shivi and Dr. Kiran Yadav. In this session, I will discuss about the wave-particle duality, which is a very basic postulate of quantum mechanics. So let's begin. Wave-particle duality postulates that all particles exhibit both particle and wave properties. Initially, light was thought either to consist of waves or particles. So according to Huygens theory, light was considered a wave, but in Newtonian mechanics, light was considered as a particle. The first to publicly hypothesize about the nature of light, proposing that light is a disturbance in the element air, was Aristotle. However, Democritus, who was the original atomist, argued that all things in the universe are composed of individual subcomponents, that means particles. So there were two different theories concerning the nature of light. One theory told that the light has wave behavior, and according to the other theory, the light is composed of particles. Through the work of Max Planck, Albert Einstein, Niels Bohr, and many others, current scientific theory holds that all particles have a wave nature and vice versa. This phenomena has been verified not only for elementary particles but also for compound particles like atoms and even molecules. So let's discuss more about what is wave-particle duality. The wave-particle duality is the principle of quantum physics. It says that matter and light exhibit the behaviors of both waves and particles depending upon the circumstances of the experiment. So any matter can behave as wave at some time and can also behave as particle at some other time. So it has both nature, wave and particle. It is a complex topic, but one of the most intriguing one in physics. Now, wave-particle duality in light. Light is able to function as both a particle and wave, depending on how the experiment is conducted and when observations are made. Under certain conditions, such as when we shine it through narrow slits and look at the result, it behaves as only a wave. Under other conditions, such as when we shine it on a metal and examine the spray of electrons that comes off, light behaves as only particles can. This multiple personality of light is referred to as wave-particle duality. Light behaves as a wave or as particle depending on what we do with it and what we try to observe. Just like light, matter is also capable of exhibiting properties of both wavelengths and particles. Massive objects exhibit very small wavelength, so small in fact that it's rather pointless to think of them in a wave form. However, in small objects their wavelength is observable and in some cases significant. Now let's see what are the significance of this discovery. This discovery allows the behavior of light and matter to be able to be explained through the use of a differential equation which represents a wave function, which is at the heart of quantum mechanics. We need the concept of alternating electromagnetic fields to explain certain physical phenomena like the interference pattern in the two-slit experiment. So we keep that. We must somehow explain how a particle orders of magnitude smaller than the distance between the slits somehow passes through both slits and interferes with itself. However, we cannot explain this well using quanta, or I can say particles or photons. Wave mechanics gives a simple, easy to understand explanation of this phenomenon. We need the concept of quanta, or the particle nature of light, to explain other phenomena like the photoelectric effect. So we keep that too. But that means we use two different mutually exclusive systems of mechanics to explain electromagnetic radiations. So this was all about wave particle duality, and I hope this is clear to you. If you have any doubts, you can mention in the comments. Thank you.